Hi everyone, welcome back to chemistry. In this video, we're going to go over Boyle's law, which is one of the gas laws. And while we're talking about Boyle's law, we'll also go over pressure. So the second bullet point, second Roman numeral on your study guide. So turns out there's an inverse relationship between the pressure and volume of a gas. And we can express this mathematically using Boyle's law. And we'll talk about what Boyle's law actually is. So inverse relationships means an inverse relationship is when changes occur in opposite directions. So if volume increases, the pressure decreases. Okay, that's an inverse relationship. So instead of when one thing increases, the other thing increases, it's when one thing increases, the other thing decreases. It's the opposite. So provided the temperature and the number of moles of the gas are constant, when volume increases, we know that pressure will decrease. So that's Boyle's law kind of stated in a sentence. So Boyle's law, like I said, states that the pressure of a gas is inversely related to its volume when temperature is held constant. So if you look over here at these containers, we have a movable piston with a gas inside the container. And as we push that piston down, we're creating more pressure, right? Because we're forcing that gas into a smaller volume. Whereas over here, it's in a larger volume, right? The pressure's lower. You can see the pressure's at 1 atm. When we push the piston down, our pressure gets higher and our volume gets lower. Okay, so inverse relationship. So we can express this concept using this mathematical equation, which is Boyle's law. P1V1 equals P2V2. So that P1 is the initial pressure, right? So if we're looking at our piston example, our initial pressure is 1 atm. And our initial volume, V1, is 4 liters. And then our final, or P2, our final pressure is 2 atm, and our final volume is 2 liters, okay, when we move that piston down. So kind of similar to M1V1, M2V2, our dilution equation, you're going to pick, okay, which one's my initial and which one's my final, and those will be corresponding to your 1s and 2s, these 1s and 2s here. All right, so let's see how this works in an actual sample problem. So a sample of oxygen gas has a volume of 12 liters at 600 millimeters mercury. What's the new pressure when the volume changes to 36 liters at a constant temperature and N? So first, we haven't seen this N before. What do you think N might stand for? So if you happen to say number of moles, you'd be correct. So N actually stands for the number of moles of our gas. Okay, so in this case, we have oxygen gas. So assuming that we keep that oxygen gas sample at the same temperature and we don't add or remove any of our moles of that gas, right? We have the same amount. Then we can use Boyle's law to kind of solve this equation. So you'll see that variable lowercase n in further equations in the future. So make sure you remember that n stands for the number of moles. And then for temperature, we always use a capital T. Okay. All right. So let's try this out. So we got P1V1 equals P2V2. And remember, this equation will be given to you on the exam. All right, so the first thing I like to do when I look at these equations or at these types of problems is I like to kind of assess what I have and what I want. So I'm noticing that I have a volume. I have pressure, right? This is 600 mmHg, millimeters mercury. That's units of pressure. How did I know it was volume? If they didn't tell me that it was a volume, I would look at the units and I'd say, okay, liters is a way of measuring, it's a unit of volume. Okay, so I have a volume and a pressure, and then I have a new pressure. So a new pressure. So let's go ahead and start labeling these 1 and 2. So my initial volume, I'll call V1. My initial pressure, I'll call P1. And my new pressure, I'll go ahead and call P2. And my, it says, what is the new pressure when the volume changes? So my final volume, I'll call V2, is 36.0 liters. So those are that's my first thing that I do, is I just determine what I have and what I don't have. So it looks like I've got a value for V1. I have a value for P1. I have a value for, let's go, V2. And I don't know my value for P2. So we'll put that one in pink. Okay, so I have V1, P1, and V2, and I want to solve for P2. So let me go ahead and color code this. So I got my P2, I got my P1, I got my V1, and I got my V2. All right, so let's go ahead and plug these values into our equation. So my P1 is 600 mmHg. I keep the units in there so that I can make sure that I'm in the correct units at the end. I have a V1, which is 12.0 liters. And then P2 is what I'm solving for, so I'll leave that just as P2. And then I have times my V2, which is 36.0 liters. All right, so my goal is to get P2 alone. So we gotta divide each side by 36.0 liters. Divide by 36.0 liters. Okay, and that's gonna allow me to cancel that V2 out. I'm just going to do a little switcheroo here, put P2 on the left, and then let's go ahead and plug that into our calculator. So first, let's do a quick unit check. So looking at these units, I have millimeters mercury in the numerator, multiplied by liters, and then divided by liters. So if I am multiplying by liters and then dividing by liters, we can cancel those out, right? Just like in our dimensional analysis problems. Okay, it's in the numerator and the denominator, so we can cancel that out. So then I'm just left with millimeters mercury. And let's just double check. Is that the unit I want to be in? Yeah, because I wanted the pressure when the volume changed. Okay, I want the new pressure, P2. Units of pressure are millimeters mercury, ATMs, stuff like that. This one didn't specifically say that it wanted it in millimeters mercury, but you can go ahead and assume that it does unless it tells you specifically that it wants you to convert to ATMs. Okay, that's kind of a good rule of thumb. Okay, so 600 times 12 divided by 36 is going to be 200. Oops, I did that in red. 200 mmHg. And let's do just a quick double check of our sig figs. So we've got one there, one SF here. We've got 3 SFs here, and we've got, looks like 3 sig figs here. So we're gonna have to go with, oh, I missed my decimal point here. So actually that makes this 3 sig figs. I was wondering why that was expressed in 3 sig figs here. Yeah, so 3 sig figs in my final answer. So I'm gonna go ahead and put that decimal point there. Okay. All right, so that's my new pressure when I change the volume to 36 liters. All right, let's try another learning check here. So this says if a sample of helium gas has a volume of 120 milliliters and a pressure of 850 millimeters mercury, what's the new volume if the pressure is changed to 425 millimeters mercury at a constant temperature and number of moles or amount? Okay, so again, one thing I wanted to mention is that in the future, when you're solving these gas law equations, I'm not necessarily going to tell you, hey, you're going to use Boyle's law, right? So I won't always tell you that. So you're not always going to know exactly which equation to use just right off the bat. But you can figure it out based on what you are, like what numbers you're given. So if we have, so let's look at this. So we've got a volume of 120 mils. So I'm going to say that's a volume. Okay. And then I have a pressure of 850 millimeters mercury. That's a pressure. I want to know a new volume. So V. If the pressure is changed, so that's another pressure, at a constant temperature and number of moles. All right, so let's see here. Now it's a matter of figuring out, I know I have units of pressure and volume, and I know Boyle's law has pressure and volume in it, so it's P1 V1 equals P2 V2. So now it's a matter of figuring out which one's P1 V1, which one's P2, and which one's V2. All right, so let's figure out which one's my initial, and we'll call those P1, V1. So we'll say, let's see, sample of gas has a volume. So I already have a volume of 120 mils, so that's my V1. And my pressure, my initial pressure is 850 millimeters mercury. My new volume is what I'm solving for. And my pressure, my P2 is 425. All right, so let's go ahead and I'm just going to color code the one we're looking for this time. Okay, so V2 is the one that we're solving for. So let's go ahead and plug these values in. Now, again, as always with algebra, you can solve this equation for your unknown variable before plugging in any values. Whatever works better for you. I typically like to just plug my values in and then solve, but some people really like to solve the algebraic equation first. So let me show you how that's done if you'd like to do that. So I know I'm solving for V2, that's my unknown. So if I want my unknown to be alone, I have to do the opposite of the current mathematical operation. So right now, these two are being multiplied together. So I've got to divide to get rid of that P2. So I'm going to divide each side by P2. And then that'll cancel out that P2 value. And I'm left with V2 equals everything on this side. So P1 V1 over P2. If you don't see how I got the equation looking like this, typically the convention is to show your unknown variable on the left and your the equation to solve for that unknown variable on the right. So all I did was I just flipped it. So I took my V2 and I put it on the left, and then I just took everything on the left and put it on the right. Okay, all right, so I'm solving for V2. So now what's kind of cool when you do it this way is you just plug in your values and you've already got your answer. So let's go ahead and do that. So we've got our P1 is 850 mmHg. My V1 is 120 mils. And then my P2 is 425 mmHg. All right, so let's see, what does that equal? So actually we'll just do down here, V2 equals, and notice we can cancel out, we want to end up in a unit of volume. Cancel out our mmHg, and we're left with just our units of volume, right? We have millimeters mercury on the top and the bottom, so we can get rid of those, and we're just left with mils, which is perfect because that is a unit of volume. All right, so let's see what that actually equals. Get a number out of this. So 850 times 120 divided by 425 is 240. 240 ml. And I see that's on my list of options, but let's just double check our sig figs just for fun. So it looks like we have 2 sig figs here, 2 here, and 3 here. So we got to go with the lowest number of sig figs because we're multiplying and dividing. All right, so that's it for Boyle's law, which gives you the relationship between pressure and volume if we hold temperature and moles constant. And in the next video, we'll go over Charles' law.